Hey everyone, welcome to My Max Academy. In this video, we'll continue with chapter 1, which is relations and functions from 12th standard CBSE. So we'll continue with exercise 1.1, exercise 1.1 in page number 5, problem 2. In exercise 1.1, it says, show that the relation R in set R of real numbers. So our given set R is stylish R, which is set of all real numbers. R is set of all real numbers. And what is the relation defined on R? This is given. Given in the question is this. And also what is R? R equal to set of all. So this R is set of all real numbers. This R is relation. So don't get confused with these two R's. This R is our real number, set of all real number, and this R is a relation that is defined on this set R. So R is a relation. So if I write like this R, it means set of all real numbers. I call this as stylish R. If not, if I just write simply an R, then it is a relation. It is defined as set of all A comma B. Set of all A comma B such that A is less than or equal to B square. This is the relation. Now what we should prove? So to prove is, see here they are not asking us to check. Here we need to prove that it's neither reflexive, nor symmetric, nor transitive. We should prove that neither reflexive, nor symmetric, nor transitive. So we should prove, which means we should prove that it is not symmetric, we should prove it is not reflexive, not symmetric, and not transitive. Right? So proof. So proof is, first we should prove that it is not reflexive. Now if the given set is R is what? Set of all real numbers, an infinite set. And again your R equal to set of all A comma B says that A is less than or equal to B square. This will also be an infinite set. So we cannot write R in terms of roster form. We can't list the elements of the relation R. So now we'll have to check whether it is reflexive. We should prove that it is not reflexive, not symmetric, not transitive. They have said it is not reflexive. But we have to prove that. We have to prove that it is not reflexive, we have to prove that it is not symmetric, we have to prove that it is not transitive. So proving it is not reflexive or not symmetric or not transitive is easier than proving it as symmetric, reflexive, symmetric, and transitive. So to prove that it is not reflexive, we should take one element from R and we should say that that element is not related to itself. Suppose, see, this R will have elements like this. Suppose it will have elements like 2, 3 will belong to this, because 2, 3 will belong to R, because 2 is less than or equal to 3 square. 2 is A comma B, because A is 2, 2 is less than or equal to 3 square. So 2 is less than or equal to 9, which means 2, 3 will belong to this set. So similarly, all the pairs, ordered pairs, which satisfy this condition, they will belong to this R set. So this is how this R set, relation set. I just took one element to make you understand what type of elements will be in this set R, in this relation set R. Now we should prove that it is not reflexive, which means we should take one element from that set and then we should prove that that element is not related to itself. Which means we should prove that A is less than or equal to, A is not less than or equal to A square. We should prove that A is not less than or equal to A square. Then only A comma A will not belong to R. So we should prove one element in such a way that that element is less than or equal to the square of its element. Suppose if we try to take 2, 2. Suppose if we take 2, 2, then 2 is less than or equal to 2 square, which means 2 is less than or equal to 4. Yes, it is true. Now let's check whether 3, 3. 3, 3 is less than or equal to 3 square. Yes, because 3 is less than or equal to 9, which is also true. So everywhere it is coming true. But we have to prove that it is not reflexive. Then let's try to consider a number between 0 and 1. Let's take a number. Suppose if I take x as half, let's say let half belong to let's take half belong to this R, which is set of all real numbers. Then then half comma half 1 by 2 comma 1 by 2 will not belong to the relation R. See, this R and this R are different. So 1 by 2 comma 1 by 2 will not belong to R because 1 by 2 is not less than or equal to 1 by 2 the whole square. 1 by 2 comma 1 by 2 will not belong to R because 1 by 2 is not less than or equal to 1 by 2 the whole square, because 1 by 2 the whole square is what? 1 by 4. Is 1 by 2 less than or equal to 1 by 4? 1 by 2 is not less than or equal to 1 by 4. Right? So therefore, even if it fails for one element, I took one element from R, set of all real numbers from this R, and we have shown that that element is not related to itself, which means A comma A does not belong to R. If it belongs to R, then it becomes reflexive, and it should belong to R for every A. Even for one element A, if it fails, then we'll say it is not reflexive. Therefore, R is not reflexive. R is not reflexive. Now, this is for the first one. Second one is we should prove it is not symmetric. So, we'll say let. We'll take one pair such that A comma B belongs to R, but B comma A should not belong to R. Right? Let's consider this element. Say suppose 1 comma 2, it belongs to R. Right? Why 1 comma 2 belongs to R? This R is this R, not this R. So here we are taking for reflexive, you should take an element from A set, which is this R set. For symmetric and reflexive, you should take the element from the relationship, which is this set. So let 1 comma 2 belongs to R, right? Because why it belongs to R? It belongs to R because 1 is less than or equal to 2 square. It is true. 1 is less than or equal to 2 square means 4. 1 is less than or equal to 4 is true. Therefore, 1 comma 2 belongs to R. But the reverse, 2 comma 1 does not belong to R. Why 2 comma 1 does not belong to R? Because 2 is less than or equal to 1 square. Can you say 2 is less than or equal to 1? No, 2 is not less than or equal to 1 square, because 1 square is 1. Is 2 less than or equal to 1? No. So which means 2 is not less than or equal to 1 square. Therefore, it does not belong to R. So 1 comma 2 belongs to R, but 2 comma 1 does not belong to R. Therefore, R is not symmetric. Even for one element, if it fails, there are many elements you can say. You can say 1 comma 3 belongs to R because 1 is less than or equal to 3 square. But 3 comma 1 does not belong to R because 3 is not less than or equal to 1 square. We have to apply this condition. This is A, this is B. If this belongs to R means A is less than or equal to B square, which means A is 1. So 1 is less than or equal to B. B is 2, B square. So you can take an element 1 comma 2, 1 comma 3, 1 comma 4. All those elements will fail, which means R is not symmetric. It is not reflexive. The third one is for transitive. We have to prove that it is not transitive. The transitive, we have to be little careful to show that it is not transitive. So for that, what I will do is I will take some number which is very close to square of a number. So I will take, let I have to take two numbers, A comma B and B comma C belongs to R. So I will take the number in such a way that I will take a number which is very close to square of a number. I will take 24, which is very close to 5 square. 5 square is 25. So I will take my A as 24, my B will be 5. So 25 comma 4 belongs to R. Why 24 comma 5 belongs to R? 24 comma 5 belongs to R. Why 24 comma 5 belongs to R? Because 24 is less than or equal to 5 square. 24 is 5 square is 25 and 24 is less than or equal to 25. So A is less than or equal to B square means A comma B, which means 24 comma 5, not 24 comma 25. 24 comma 5 will belong to R. So let it belongs to R and right, and we'll take some other number and which we should start, it should start from 5. So 5 is obviously 5 comma 3 will belong to R. Why 5 comma 3 will belong to R? Because 5 is less than or equal to 3 square. 5 is less than or equal to 3 square is what? 9. So we have taken two elements. 24 comma 5 belongs to R because 24 is less than or equal to 5 square, and 5 comma 3 belongs to R, which means 5 is less than or equal to 3 square. That's why 5 comma 3 belongs to R. So if you take such a pair, it will fail. If you take other pairs, you may feel that it is satisfying. So you have to choose your A in such a way that it is very close to square of a number. You can even choose this as 17. How say 15? You can choose this as 15 and you can put here 4. And 15 is less than or equal to 4 square. So your A should be in such a way that it is very close to square of a number. I'm just taking 5 as the number. So 5 square is 25. I'm taking A as 24 and B as 5. So 24 comma 5 belongs to R, and I have to take the same number. If it is 5, I should start with 5 here because it is A comma B, B comma C. I cannot take any other number here. This must be 5 because this is ending with 5 means the next element. Next A comma B, then B comma C. So these two should match. B. Fine. So B comma C belongs to R and this belongs to R because 5 is less than or equal to 3 square. This satisfies this condition. Your A is 5, B is 3. So which means we'll say 24 is, this implies 24 is less than or equal to 5 square and 5 is less than or equal to 3 square. But 24 is less than or equal to 3 square. Right? So which means this means that 24 is less than or equal to 3 because 3 square is 9. 24 is less than or equal to 9. No. So therefore 24 comma 3 does not belong to R. So what we have proved? We have proved A comma B belongs to R, B comma C belongs to R, but A comma C means 24 comma 3. 24 comma 3 does not belong to R because 24 is not less than or equal to 3 square. This is A. Now A, C. A is not less than or equal to C square. 24 is less than or C square. No. Okay, I have to put not. 24 is not less than or equal to C square. 24 is it's not less than or equal to 3. 3 square is 9. Is 24 less than or equal to 9? No. So it is not. So if you put the symbol and strike it out, it is not. So therefore, R is not transitive. We can find many numbers like that. So you have to choose your A in such a way that A is very close to or number 1 less than square of any number. You can take this as 35 also. If you take this as 35, you should take this as 6. Because 6 square is 36 and you are taking a number less than that. Then according to once it is 6, you will start with 6 and then you take the next number in such a way that the square of that number is just greater than 6. Which means 2 square I cannot take. It will become 4, but 4 is not 4 is smaller than 6. We need a number greater than. Again I can take 3. 3 square is 9. So this is 6. So 6 is less than or equal to 3 square. Then we can say 35 is not less than or equal to 3 square. Therefore 35 comma 3 does not belong to R. Therefore R is not transitive. Right? So this is how we will show that this given relation is neither of these three. Fine. So all of you pause the video, take the notes. I'll go to the third problem. Probably I will say you can third problem is simple only, anyways. I'll do that. It's okay. So what is the third problem? Third problem is what is given? Given is given in the question is A set is given, which is defined on the set. So I'm taking that set as A, which is 1, 2, 3, 4, 5 and then 6. And your R relation that is defined on the set A is set of all A comma B such that A is equal to B plus 1. Oh, sorry, B is equal to A plus 1. B is equal to A plus 1. Now we should check whether it is reflexive, symmetric. They are not saying it is not reflexive, not symmetric. We have to check whether it is reflexive, symmetric and transitive. So to check if R is reflexive, symmetric and transitive. We have to check this, which means we don't know whether it may be reflexive or not reflexive, symmetric or not symmetric, transitive or not transitive. We have to check this, right? So for that, how do we write the proof? See, if it is A set is given, based on this condition, if I say A is a small set, it has only 6 elements, so we can try to list down the elements of R. So which means we can write the relation set R in the roster form. because it is going to have only few elements. So how do we write this R? R equal to, it should, so any element that satisfies this condition. So which means, and those elements will come from A cross A set, which means we should take 1 comma 1 and then check this condition. And 1 comma 2, whether 2 is equal to 1 plus 1. So we have to check this condition. So what we can do is, I'll put the value of 1 for A here and find the value of B. So if I put 1 for A is 1, comma, B becomes 2. Right, comma, then if I put A equal to 2, B becomes 3, 2 comma 3 will come. If I put A equal to 3, so 3 comma 4 will come. Then 4 comma 5 will come. And 5 comma 6 will come. Right? If I put 6 for A, then B will become 7. If I put A as 6, B will become 7. But 7 is not in the set. So you should write the element, both these elements, 3 and 4, as both are 4 and 5. Everything should come from this set A. Right? So this is our relation set. So we have written the given relation which is in the set builder form to the roster form. Set builder form to the roster form. Now we need to check whether it is reflexive. So clearly it is not reflexive. So R is reflexive means what? We should have 1 comma 1 belongs to this. R 2 comma 2, 3 comma 3, all these should be in this. But none of them is there. So we'll say we can take one element, right? Let 1 belongs to A. Or we not even say let, because 1 belongs to A. 1 belongs to A, but 1 comma 1 does not belong to R. Therefore, R is not reflexive. R is not reflexive relation. So the first part is done. We have disproved that it is not reflexive, because sometimes when you look at the set itself, we will know that it is not reflexive. Then again, for symmetric, see 1 comma 2 is there, but the reverse 2 comma 1 is not there. Therefore, it is not symmetric. So we can say 1 comma 2 belongs to R, but 2 comma 1 does not belong to R. Therefore, R is not symmetric. R is not symmetric. The third one is transitivity. Transitivity, we have 1 comma 2 is there and 2 comma 3 is there, but 1 comma 3 is not there. So it is failing for this pair. Or you can take any pair. For this pair also 2 comma 3 is there and 3 comma 4. So A comma B, B comma C, but A comma C, which is 2 comma 4, is not there. Therefore, it is not transitive. So we can take one pair. So we'll take this pair. So I'll say 1 comma 2 belongs to R and 2 comma 3 belongs to R, but 1 comma 3, A comma B belongs to R, B comma C belongs to R, but 1 comma 3 does not belong to R. Therefore, R is not transitive. R is not transitive. Fine. So this is the proof. So we have proved that. We have checked that, and it is not reflexive, not symmetric, and not transitive. Fine. So let's go to the fourth problem. The fourth problem is actually exactly similar to the sorry, not the fourth one. Fifth one is similar to the second one. We'll do the fourth one. So fourth one says that show that the relation defined on R defined by. So what is fourth one? I'll write here. For the fourth one, the given condition is the fourth problem. The given condition is that the set is R. The given set is R is stylish R. Set of all real numbers. Set of all real numbers. R is set of all real numbers, and this is your real number set, and the R set is defined as the R set relation set is defined as set of all A comma B such that A is less than or equal to B. Is reflexive and transitive but not symmetric. We have to prove this. It's reflexive and it is reflexive and transitive but not symmetric. We have to prove this. Show that. So to prove, what we have to prove? We have to prove is reflexive. R is reflexive, comma transitive, but not symmetric, but not symmetric. No proof. Now to prove that it is reflexive, we cannot take one element and say, one belongs to R, the set of all real numbers, so 1 is less than or equal to 1, therefore 1 comma 1 belongs to R, therefore it is reflexive. We can't take one example and say that it is satisfying the conditions, therefore it is reflexive. You have to write the proof. If you have to prove that it is reflexive, or you have to validate for each and every element in this R. That is not possible because it's an infinite set. Because R is an infinite set, therefore this relation also will give you infinite set. Right? So now to prove reflexive, we'll have to prove generally. So we'll take one element. Let A belongs to this set R, which is set of all real numbers, stylish R. Then what we have? Then we have A is less than or equal to A, correct? For every A belonging to set of all real numbers, stylish R. A is less than or equal to A. It's always true, right? 1 is less than or equal to 1, 2 is less than or equal to 2, 3 is less than or equal to 3, 1 by 2 is less than or equal to 1 by 2. So it is true for every R, very real number. Therefore, we can say A comma A belongs to R. This R is different from this R. This R is relation R. Therefore, R is reflexive. Therefore, we can say R is reflexive. So we have proved that R is reflexive. Now we need to prove R is transitive, but we should prove it is not symmetric. We'll prove not symmetric, then we'll prove it is transitive. Now for not symmetric, what do? We need to take one element. A comma B should be in R, but B comma A should not be in R. Even if one element exists like that, then we can say it is not symmetric. So we'll try to choose one element from here. So second part, this is for the first part. Second part is, we'll say we'll choose one of the elements. We'll say 1 comma 2 belongs to R. Why 1 comma 2 belongs to R? Because 1 is less than or equal to 2. A is less than or equal to B. But 2 comma 1 does not belong to R. 2 comma 1 does not belong to R because obviously 2 is not less than or equal to 1. 2 is not less than or equal to 1. Therefore, R is not symmetric. Even for one element, if it fails. So 1 comma 2 is in R, but 2 comma 1 is not in R. These R denotes the relation R, not the set R. Not the set of all real numbers. It denotes the relation set R. Therefore, R is not a symmetric relation. Now, we have to prove that it is transitive. We will show that it is transitive. Show that transitive means we can't take one example and show that it is working, so it is transitive. We have to write the proof for transitivity. So, which means we should take two elements. So, let A comma B belongs to R, right? A comma B belongs to R and B comma C belongs to R. Which this means A comma B belongs to R means A is less than or equal to B, and B comma C belongs to R means B is less than or equal to C. When A is less than or equal to B and B is less than or equal to C, then we can say A is less than or equal to C, right? So if 2 is suppose less than or equal to 5 and 5 is less than or equal to 7, then I can say 2 is less than or equal to 7, right? That is always true, right? If A is less than or equal to B and B is less than or equal to C, means A is less than or equal to C. Now A is less than or equal to C as per this definition. When A is less than or equal to C, then A comma C will belong to R. So this implies A comma C belongs to R. Therefore, R is transitive. Therefore, R is transitive because we took two elements. A comma B belongs to R and B comma C belongs to R, and we proved that A comma C belongs to R. Therefore, it is transitive. Here we did not take one particular element. We have taken some general two pairs. Any A and B and any B and C, you will get A and C belongs to R. Therefore, it is transitive. Fine. So now let's go to the fifth problem. All of you pause the video and take the notes. I am erasing this. So we are still in exercise 1.1. We are still doing exercise 1.1, fifth problem from the textbook. So what is given? The given is, again relation is on R. Given is R, stylish R, which is set of all real numbers. Set of all real numbers. And the relation set R is defined as, so this fifth problem is similar to the second problem that we did. similar to the second problem. Exactly, we have to follow the same logic to prove it is symmetric, reflexive, and transitive. So R is defined as set of all A comma B such that A is less than or equal to B cube. Is now what we have to check. To check is if R is reflexive, symmetric, and transitive. To check, it's a question mark. They're not saying prove it. We have to check. Check means it may or may not be. If they say prove that it is reflexive, means it is reflexive, but we have to prove that it is reflexive. So here we don't know it is reflexive, symmetric, transitive. So we'll have to check. Now for reflexive, what do we do? The first one, reflexive. To check reflexive, we'll take one element from R. And if that element is not related to itself, which means A comma A, we should say A comma A does not belong to R, means it becomes not reflexive. Now again the same logic. If you do any number between 0 and 1, this condition will fail. Suppose we'll take a number, again we'll take the half. 1 by 2 belongs to R, and this R is real number, set of all real numbers, stylish R. 1 belongs to R, but when 1 by 2 belongs to R, 1 by 2 belongs to R means 1 by 2 comma 1 by 2, this does not belong to the relation set R, this set R, because 1 by 2 is not less than or equal to 1 by 2 the whole cube. A is less than or equal to A cube. It's not true. A I have taken it as 1 by 2. 1 by 2 is not less than or equal to 1 by 2 the whole cube, because 1 by 2 the whole cube is 1 by 8. And 1 by 2 less than or equal to 1 by 8? No. 1 by 2 is greater than 1 by 8. So that's why I have said not equal to. Not less than or equal to, which means 1 by 2 is greater than. So this condition is failing for the number 1 by 2. Therefore, R is not reflexive. So any number that you can even take 1 by 4. Then 1 by 4 comma 1 by 4 does not belong to R, because 1 by 4 is not less than or equal to 1 by 4 the whole cube, because 1 by 4 the whole cube is 1 by 64. And your 1 by 4 is not less than or equal to 1 by 64. 1 by 4 is greater than 1 by 64. So therefore you can say R is not reflexive. So if you choose any number between 0 and 1, this condition will fail. So therefore R is not reflexive. Then we should check for whether it is symmetric. So again for symmetric we can take easy path. We'll say let 1 comma 2 belongs to R. Why 1 comma 2 belongs to R? Because 1 is less than or equal to 2 cube. 1 is less than or equal to 2 cube. This condition is satisfied. 1 is less than or equal to A is 1, B is 2. B is not 2 cube, B is 2. And A is less than or equal to B cube, therefore A comma B will belong to R. And people will get confused. They'll think this 1 is less than or equal to 8. 2 cube is 8. They'll think A is 1, B is 8. B is not 8, B is 2. So 1 comma 2 belongs to R because 1 is less than or equal to 2. Which means 1 is less than or equal to 2 cube is 8. 1 is less than or equal to 8 is 2. Therefore 1 comma 2 belongs to R. But 2 comma 1 does not belong to R, because 2 comma 1 does not belong to R because of the condition that 2 is not less than or equal to 1 cube. 2 is not less than or equal to, the meaning of this is 2 is not less than or equal to 1 cube, because 2 is not less than or equal to 1 cube is what, 1. 2 is less than or equal to 1? No. So therefore R is not symmetric. So it is not symmetric also. Not symmetric, not transitive. Now, sorry, not reflexive, not symmetric. Now we have to check whether it is transitive or not. So how do we check transitivity? Again for transitivity, we will take the third part. We need to choose a pair like this, A comma B and B comma C, and we should show that A comma C is not there in R. So how do we prove this? So for that, let's take a number which is very close to cube of a number. Let's take, suppose 27 is 3 cube. We'll take a number which is very close to 3 cube. 3 cube is 27. So we'll take A as 26. So we'll say 26 comma 3. It belongs to R. Why 26 comma 3 belongs to R? Because 26 is less than or equal to 3 cube. 3 cube is, don't say 9, 3 cube is 27. 3 cube is 3 into 3 into 3. 26 is less than or equal to 27. So that's why 26 comma 3 belongs to R. Because this condition is satisfied. 26 is less than or equal to 3 cube. 3 cube is 27. So 26 comma 3 belongs to R. Then, and we should take 3 comma something. That 3 comma something, that number, the cube of that number should be, the 3 should be less than the cube of that number, which means we can say 2. Because 3 comma 2 belongs to R, because 3 is less than or equal to 2 cube, because 2 cube is 8 and 3 is less than or equal to 8. So this is how you will choose your A, B and C. First you will choose A and B in such a way that your A is very close to cube of B. So I'll take, if I take B as 3 cube is 27, I will take A as 26. Then 26 comma 3 will belong to R. Then this is 3 means this also should be 3. And you have to choose another number C such that the cube of that number should be, this B should be less than or equal to cube of that number. So which means I will take 2. I can't take 1 because 3 is not less than or equal to 1 cube. I'll take 2. Don't take 3 because 3 is less than or equal to 3 cube also. Don't take that because that may not satisfy. So take 2. The immediate cube that is greater than 3. So which is 2 cube? 2 cube is 8. So 3 is less than or equal to 8. So now A comma B belongs to R and 3 comma 2 belongs to R because 3 is less than or equal to 2 cube. So these two elements belong to R, but 26 comma 2 does not belong to R because why it will not belong to R? A comma B belongs to R, B comma C belongs to R, but A comma C does not belong to R because your 26 is not less than or equal to 2 cube because your 2 cube is 8 and 26 is not less than or equal to 2 cube. 26 is greater than 2 cube, which means 26 is greater than 8. Therefore, we will say, therefore, R is not transitive. R is not transitive. Clear? So therefore, we will say R is not transitive. So it is not reflexive, not symmetric and not transitive. Fine, clear? So all of you pause the video and take the notes. I will do the 6th problem now. Then let's do the 6th problem in the book, which is pretty straightforward. Or probably I think no, you can do the 6th problem as homework. I will give it as do it yourself. So 6th problem is homework. You can try 6th problem as homework, which is show that the relation in the set 1 comma 2 comma 3 given by R equal 1 comma 2 and 2 comma 1 is symmetric but neither reflexive nor transitive. So you can try this as homework. So I will stop the video here. You can watch my next video for the continuation of this. Thank you for watching. You can watch my next video. Thank you.